Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with solving systems. We've done some graphing stuff. We've graphed equations. We've graphed linear inequalities. And so you can do any of these things, but so graphing is just where lines cross or where shaded sections overlap here. But we can also use substitution, like in 2.4, we can use elimination. We can also do algebra to figure out where graphs are going to cross or kind of be solutions. So today's section is 2.5. We're solving systems using elimination. Our essential question is, how do we solve systems using elimination? So for our warm-up here, it says it wants you to find the lowest common denominator, or LCD, for these fractions. We need to find the least common multiple to do this. Go ahead and see if you can figure this out. All right, so yeah, a lot of us probably have practices from middle school. So the answer for the first one between 2 and 5 is 10. And basically that's the smallest number that divides by both numbers, right? And so the way that I do this, just for kind of doing this, where multiples are 2, 4, 6, 8, 10, right? And 5, 10, 15, okay? Oops. 5, 10, 15. So the smallest number would be 10. That divides by both of these, right? Multiples means you count up by that number and kind of double, triple, quadruple kind of thing, right? What I do is I start with the bigger number between 2 and 5 would be 5. I count up by 5. So I say, does 5 divide by 2 and 5? Well, it divides by 5, but not 2. So then we go to 10. Does 10 divide by 2? Does 10 divide by 5? It does. This would be the least common multiple they have that would actually divide by both of them. So 10 is the least common denominator here. Okay? Now we've gone through that. If you'd like to try the second one, go ahead. All right, so the bigger number here is 8. We count up by 8. Well, does 8 divide by 4 and does 8 divide by 8? It does. So actually 8 is the least common multiple here, which is fine. It can be the actual, you can have a denominator that's already kind of set for that. But yeah, so 8 is going to be the least common multiple or the lowest common denominator. And so this will be useful for today for elimination. You'll see why in a little bit. All right, we got some blanks to fill in here for how to solve systems using elimination. I want you to see if you can fill in these blanks. Go ahead. All right, so with substitution, we need to get x or y by itself. Elimination is a little bit different. The first thing we need to do is we need to line up all the variables. We need to what? Line up all the variables. We need x over x, y over y, etc. Number 2, we need to make sure one of the variables are opposites. Are what? Opposites. So what does opposites mean? If you had, for example, negative 7x and 7x, these would be opposites. If you had 4x and negative 3x, these are not opposites because they're not the same exact number, opposite signs, okay? If they are not opposites, then you're going to multiply. You're going to what? Multiply one or both equations to get opposites. Okay. Next, when we have opposites, we're going to add the equations. We're going to what? One variable should cancel or eliminate. Okay. And so after that cancels, you're going to solve for the variable that did not cancel. Then we're going to plug that answer into one of the equations to get the other variable. The other what? Variable. So we solve for x, you want to solve for y, and vice versa. Okay? You may get weird results. Your answer should be an ordered pair like 2, negative 1. What were the weird results again we had for substitution? We had no solution or infinite solutions are some options. All right, so now let's go ahead and do we're going to kind of scaffold here. We're going to build up to some harder problems. We'll see how we do. So let's do number 1 first. We have negative 4x minus y equals 2, and negative 9x plus y equals 24. First things first, is everything all lined up nicely? It is. We have x over x, y over y, constant over constant. Next thing we need to check is one of these, the numbers in front of the x or the y, are they opposites? Well, negative 4 and negative 9 are not. How about negative y and positive y? Well, yeah, that's like negative 1y and positive 1y. So these are opposites, so we're good there. So once we have opposites, we're going to put a line underneath here, and we're going to add straight down. So what's going to happen when we add these? Well, negative 1y plus 1y, they're going to cancel out. And that's what it's called. They're actually going to eliminate, right? That's why this works, because it cancels out. We add the rest, negative 4x plus 9x is negative 13x. And then 2 plus 24 is 26. Now we can solve from here. How do we do that? Divide by negative 13. All right, and then that's going to give us x equals what, negative 2? Are we done? We are not. We need to go ahead. We need to plug in and solve for y now. Which equation would be nicer to solve for, do you think? Could do top or bottom. I'd probably do the bottom one because we have a positive 1y, which is kind of nice. It's a little easier to work with than negative y. So we got negative 9x plus y equals 24. We're going to plug in negative 2 in for x or for y? Plug in for x. So we have negative 9 times negative 2 plus y equals 24. Negative 9 times negative 2 is 18 plus y equals 24. Subtract 18. Y equals what? 6. So our answer as an ordered pair would be negative 2 comma 6. All right. And that's how you do it, like if everything's like all lined up and you have opposites. Why don't you guys go ahead and try number 2, which is very similar. Give it a try. All right, so first thing, do we have everything all lined up? X over x, y over y, constant over constant. We do. Do we have opposites here? We do. We got the negative 4x and positive 4x. Now we can add straight down. These are going to cancel. We get 6y plus y is going to be 7y. We got 20 minus 6 is going to be 14. All right, if you need a hint, you can pause here and keep going. We're going to divide by 7. We get y equals what, 2? All right, are we done? Now, yeah, we got to plug in here. I'm going to plug into the bottom equation because I like the positive 4x here. Work smarter, not harder. So we're going to plug in 2 in for y. So we have 4x plus 2 equals negative 6. Subtract 2. 4x equals what, negative 8. Divide by 4. And x equals what, negative 2? So our answer is going to be, it's negative 2, my bad. It's going to be negative 2 comma 2, xy. All right, and that's how we do it, how we do elimination if it's basic adding here. All right, next thing we have for 3 and 4, we have to rearrange some terms first because we need x over x, y over y, constant over constant. I should mention, too, it doesn't really have to be like x, y constant. You could do like 5y equals, 3x minus 2, and then 10y equals 5x plus 4. As long as they're lined up like this, that's fine. I just like to put x and y on the same side to kind of make it look nice, and I think it's just, I don't know, it just feels better that way to me. But it's totally fine as long as they're all lined up and in the same spot. Okay? You also got to make sure the equal sign's in the right spot. Okay, so we got this one here for number 3. We got negative 5x equals negative 17 minus 2y. We have 2y minus 10x equals plus 22 equals 0. So let's rearrange these. These are not obviously lined up here, so we're going to do negative 5x equals negative 17 minus 2y. How do I get the x and y on the same side in one step? Well, we can add 2y to both sides. So we're going to add 2y. We get negative 5x plus 2y equals negative 17. How about the bottom one over here? We got 2y minus 10x plus 22 equals 0. Well, x and y are on the same side here, which is nice. We can kind of rearrange those. We got to get that 22 to the other side. How do we do that? Minus 22. Now I'm just going to flip these two here, okay? Because commutative property says we can flip them around. It doesn't really change, as long as we just rearrange them. So we got negative 10x plus 2y equals negative 22. All right, and then from here, we can now we can kind of line these up and do our normal thing. Negative 5x plus 2y equals negative 17. We got negative 10x plus 2y equals negative 22. All right, so everything's lined up. Do we have opposites here? We're close, but we have positive 2y and positive 2y. How do we fix that? So what we're going to do here is we're going to multiply either top or bottom by something. What can we multiply the top or bottom by to get the opposite of 2? Well, I can multiply the bottom by -1, and that's going to change all the signs, right? So we go like that, multiply by -1 on everything. So top stays the same, -5x plus 2y equals -17. How about the bottom? What's that going to become? It's going to be 10x minus 2y equals 22. All right, why don't you guys go ahead and solve from here if you have not yet. Give it a try. All right, so now we add straight down. The two y's are going to cancel. We get 5x equals what? 5. Divide by 5. We get x equals 1. Are we done? Not quite. But we can actually plug into any equation we want. It doesn't have to be one of the original equations. So I think I'm going to plug into this one over here. So I'm going to do -10x plus 2y equals -22. I'll plug in this 1 in for x. -10 times 1 plus 2y equals -22. So what's that? -10 plus 2y equals -22. Add 10. 2y equals what? -12. Divide by 2. Y equals -6. So our answer for this one is going to be 1, -6. Awesome. All right, why don't you guys go ahead and try number 4. If you need another example like this, go ahead and give it a try. All right, number 4, we need to get x and y on the same side here. So we can add 3y on top here. We can also add 3x down here. That's going to kind of be a little bit easier one. So down top we have 8x plus 3y equals 26. And down here we have 3x plus 3y equals 6. All right, similar thing here. We have everything lined up. Do we have x and y on the same side? We do. Do we have opposites? We do not. We can multiply something by -1. Multiply the bottom by -1 here. Multiply everything on the bottom by -1 and keep the top the same. So -1 times 3x is -3x. -1 times 3y is -3y. And -1 times 6 is -6. Now we have opposites. We can add straight down. These are going to cancel or eliminate. 8x minus 3x is 5x equals what? 20. Divided by 5. We get x equals 20 divided by 5 is going to be 4. Not quite done yet. We need to make sure we solve for y now. So I'm going to plug into, we'll do 3y. 3y equals 6 minus 3x. Plug in this 4 in for x. So we have 3y equals 6 minus 3 times 4. So 3y equals 6 minus 12. 3y equals -6. Divide by 3. Y equals -2. So our answer for this one's going to be 4, -2. All right, sounds good. Okay, I've got a few more examples to go here, so we'll keep moving. All right, next thing we have is sometimes we kind of already started this a little bit. We need to multiply equations sometimes to get opposites. So if you guys want to pause the video and see how you do here, give it a try, but we'll go through it in a second. All right, number 5, we have -12x plus 9y equals 24. -24 and 6x plus 4y equals 12. We need opposites here. So I see the -12 and 6. Those are opposite signs, not necessarily opposite numbers. Then I have 9 and 4, which are not same. They're same signs and not opposite numbers. So I want to. This -12 is kind of intriguing me. What's the least common denominator between 6 and 12? It'd be 12, right? That's kind of when we were talking about that in the warm up. When you're doing this, it makes sense to kind of look for the least common multiple between 12 and 6, right? So 12 divides by both 12 and 6. So we're going to multiply this to get 12. How do we get 6 times 1 is going to be 12? We're going to do times 2, okay? 6 times 2. So now we have, rewrite the equation here, -12x plus 9y equals -24. And the bottom, multiply everything by 2. We're going to get 12x plus 8y equals 24. Okay, now we have opposites here, so we can add straight down. -12x plus 12x cancels. 9y plus 8y is 17y. That's going to equal 0. And that's okay. You can have equal to 0 because we can still divide by 17 right? And so y is going to equal 0. It's okay for y to equal 0. Usually it's when there's like weird things that it's not, but all right, cool. Which equation do you want to plug into now to solve for x? I might do the 6x plus 4y1. We're going to plug in 0 in for y, so we have 6x plus 4 times 0 equals 12. So 6x plus 0 equals 12. 6x equals 12. Divided by 6. X equals 2. So our answer is going to be 2, 0. All right, awesome. Why don't you guys do the same thing here for number 6, see if you can figure out what we're going to multiply by. Give it a try. Okay, for this one, you can do two things. You can cancel the x's. You can cancel x's or y's. We canceled the x's over here. So if you want to cancel the x's, I would multiply the bottom by 2, because then you'd have 14x and negative 14x, right? 14x and negative 14x. In this case, let's cancel the y's, though, to make sure we're comfortable with both. So you'd multiply by 2 to do that. But in this case, so I have 2 and 4. What's the least common multiple or lowest common denominator between 2 and 4? It'd be 4, right? So I need to multiply the top. 2 times what's going to be 4? It's going to be 2. And also, do you see how we have both positive numbers here? These are both positive. So we're going to need to multiply this by a negative 2 to make it positive 4 and negative 4. All right, if you want to go from here, figure it out, give it a try. All right, negative 2 times 14x is negative 28x. Negative 2 times 2y is negative 4y. Equals negative 24 over here. Write the rest of it the way it is. Plus 4y equals negative 11. Now we can add straight down. These cancel. We get negative 35x equals negative 35. Divide by negative 35. We get x equals 1. All right, we can plug into either of these. I kind of like the top one there, so I'm going to do 14x plus 2y equals 12. We're going to plug in 1 for x. So 14 times 1 plus 2y equals 12. 14 times 1 is 14. Plus 2y equals 12. Minus 14. 2y equals negative 2. And then we're going to divide by 2. We get y equals negative 1. So our answer should be, for xy, 1, negative 1. Be careful when you're writing your answer, too, because if you mix up the x and y, that's probably a half point off. But, yeah, just be careful. Sometimes you end up with x at the end and you kind of flip them. So, okay? All right. Okay, we're going to do a few examples here. Why don't you guys see about number 7 and 8 now, okay? So, same process as before. We're doing elimination here, but you're going to get some special results. And I want you to solve these and think about, is it going to be infinite solutions or no solution? Give them a try. See how you do. All right, so this one here, everything's lined up. We do not have opposites here, but we can multiply to get opposites. So I see 15 and 5. I see 4 and 12. Let's do 15 and 5 here. So we can do the opposite of 15. Negative 15 would be positive 15, so I can multiply by 3 here. So 3 times 5x is 15x. 3 times negative 4y is negative 12y. And 3 times negative 9 is negative 27. I got negative 15x plus 12y equals 18. All right, now if I add these, what's going to happen here? What's going to eliminate? The x's are going to eliminate, but also the y's are going to eliminate. That's kind of weird. So we get 0 over here, right? And on the right-hand side, we're going to get negative 9 if we add those. Okay, is this true or false? It's false. I think it's going to be infinite or no solutions. It's going to be no solution. Okay, so that's what it looks like when you do elimination and it doesn't work out nicely. So this would be like if you graph these lines, they would be parallel. They would never cross. And if it's like this, if it's like a true solution, it's going to be infinite solutions. Why don't you guys try number 9, which is very similar. Give it a try. Or 8, I mean, sorry. All right, same thing over here. We're going to multiply the bottom by what to cancel it? Well, opposite 12 will be negative 12, so we multiply by 4 here. So we're going to get 12x right at the top the same. Bottom would be negative 12x minus 24y equals negative 12. So now if we add these, cancel, x are going to cancel, y is going to cancel, we get 0. And 12 minus 12 is also going to be 0, so we get 0 equals 0. Is that true or false? It's true, so it's going to be infinite solutions. All right, very cool. All right, last thing we're going to talk about. Sometimes you have to multiply both equations instead of one. So like you're trying to get a lowest common multiple, but you need to or least common multiple, but you need to multiply both equations to do that. So why don't you guys pause and think about this here, about what we can do. Give it a try. Okay, so for this, I guess the least common multiple between, let's do between the x's here. We got 6, and 8, right? So you have 6 and 8. Which number's bigger, 6 or 8? Well, 8's bigger, right? So if I divide by 8, if I start at 8s, right? Does 8 divide by 8 and 6? So we have 8. So 8 does divide by 8, but does 6 divide by 8? It does not, right? So yes, we need to go up higher here. So we got 16. Actually, it should have been 8 divided by 6. That was my bad. So now we have 16. Does 16 divide by 8? It does. 16 divided by 6? It does not. Okay, then we go up to 24. Now we have 24. Is 24 divided by 6? It does. And 24 also divides by 8. So the least common multiple is going to be 24. So what can we multiply? This is going to be 24 for the negative 6x and the 8x. 6 times what is 24? 2 times 4. And 8 times what is 24? Times 3. So now it's the same thing here. We're going to multiply both top and bottom by this here. So we got 4 times negative 6x is negative 24x. Minus 24y equals 48. And bottom's going to be 24x minus 27y equals negative 48. Okay, if you guys want to solve from here, feel free. All right, we're going to add straight down. X's are going to cancel. We get negative 51y equals 0. Divide by negative 51. Oops. So we get y equals 0. Going to plug into any equation here. I'm going to plug into the bottom one here. So we got 8x minus 9y equals negative 16. Plug in 0 for y. We get 8x minus 9 times 0 equals negative 16. 8x equals 16. It's going to be 0 over there, negative 16. Divide by 8. X equals negative 2. So our answer is going to be negative 2 comma 0. All right, there we go. Why don't you guys try number 10? That'll be the last one we'll do today. See if we can figure it out. Okay, so we canceled the x's before. So if you want to cancel the x's, you could multiply the top by 3 and bottom by 2 to get 6x and negative 6x. I want to cancel the y's, though, just to get some more practice. So what would the least common multiple between 4 and 7 be? I think that's 28, right? So if we count up by 7, 7 doesn't divide by 4, 14 doesn't divide by 4, 21 doesn't divide by 4, but 28 does. So we need to multiply to get 28. So 4 times 7 is going to be 28, and on the bottom is going to be 7 times 4. So if we multiply that, we're going to get 14x plus 28y equals 14. Then we have negative 12x minus 28y equals 4. If you guys want to solve from here, feel free. These cancel. We get 14x minus 12x is 2x equals 18. Divided by 2. We get x equals 9. All right, and then we got to plug in here. I'm going to plug into the top one. Either one would work, though. So we're going to plug in this x here. So we get 2 times 2 plus 4y equals 2. And so we have 4 plus 4y equals 2. And then we have minus 4 minus 4. So 4y equals, I think I goofed something up here. Let me see. What did I goof up? Oh, it should have been 9. I put 2 here. Whoops. 9. Oops, that's not what I wanted. Stop it. Well, it's not erasing. That's great. So, anyway, so I'm going to rewrite this. So it should be 2 times 9 plus 4y equals 2. This should be 18 plus 4y equals 2. Subtract 18. This is wrong over here. 4y equals negative 16. Divide by 4. Get y equals negative 4. So our answer for this one will be 9, -4. All right. And that is all I have for you today with elimination. Thank you for watching. Have a great day, and we'll talk soon.